The equation practice video. This one's Ohm's law, V equals IR. I've written it out there for you. And V is voltage measured in volts. I is current, which is measured in amps. And R is resistance, measured in ohms. So if you want to get that written down, and then pause, I've got 3 questions for you to do. You can do these 2 first. And then I've got some more advanced Ohm's law questions incorporated within the circuit. So you'll need to know the circuit rules as well. Alright, let's make a start. Alright, let's go through some answers. So a bulb with resistance of 11.5 ohms has a resistance of 3.86 amps passing through it. Calculate the potential difference. So potential difference is just voltage. So V equals I times R. And then we simply need to put the numbers in. So the current is 3.86 amps multiplied by 11.5 ohms. And that gives us 44.4 volts. If you just put 44 volts, that's perfectly fine. All right, let's look at the second one. So a bulb with resistance of 14.1 ohms has a potential difference of 42.3 volts across it. Calculate the current. So we're going to use V equals IR, write the equation out. Then we need to get current on its own. We need to make it the subject, so we need to get rid of the times R. The opposite of timesing by R is dividing by R on the other side. And that'll give you the current. So then just put the numbers in. So it's 42.3 divided by resistance at 14.1. And that gives us 3 amps. Okay, if you want to have a go at the third one, before we start the more complex problems. So if you want to pause. Well, let's have a look. So a bulb has a current of 0.646 amps and a potential difference of 14 volts. And this time we're going to calculate the resistance. So V equals I times R. And if you want to make R the subject, we need to get rid of the times I. So obviously to get rid of the times I, we do the opposite on the other side. So the opposite of timesing by I is dividing by I. And then we just need to put the numbers in. So it's 14 volts divided by 0.646 amps. And that gives us 21.7 ohms. Alright, let's move on to some more complex circuit problems. Okay, so if you want to pause and have a go at this one. If you're not sure about the circuit rules, if you can't remember them, then you need to go back to the electricity videos that I've done on the playlist and look at the circuit, the voltage and the current, and the circuit rules videos. Failing that, let's go through the answers if you've had a go. So on this one, using the diagram above, calculate the following. So the first thing we're going to do is the total voltage. So the total voltage is simply, we've got these 2 batteries that are in series with each other. And if 2 batteries are in series with each other, add them together. So we've got the 5 and the 5 next to each other. So obviously, oops, get rid of that. 5 volts plus 5 volts in series gives us a total voltage of 10 volts. Nice and easy. So next one, total resistance. So really straightforward, total resistance. This is a series circuit, and a series circuit just means that the current can only flow in one direction, as you can see there. So in a series circuit, to get the total resistance, you simply add up the resistances. So we've got 2 to add up. We've got a 20 ohm resistor and a 30 ohm resistor. So obviously 20 ohms plus 30 ohms will give us grand total of 50 ohms. Alright, let's look at the next one. So the current flowing through each resistor. So straightforward one. If you know the rules, the current in a series circuit, as I've just said, is constant, it's the same. So the current going through the 20 ohm and the 30 ohm resistor is identical. So what we actually need to do is to calculate the total current that's in the circuit. So that's V equals I times R. Rearrange to get current, so we need to divide by R on the other side. So voltage is 10, total resistance is 50, so that gives us 0.2 amps. Right, next bit, we need the voltage across each resistor. Right, to get voltage, so I'll call this V1 and this one V2. So voltage 1 and voltage 2. Voltage 1 will be equal to the current that's going through it, which is just the 0.2, multiplied by the resistance of the component. So current 0.2 times resistance of 20 And that gives us 4 volts. And then we just need to do the same for voltage 2. The current going through it is the same, and the resistance this time is 30 ohms. So we need to do 0.2 multiplied by resistance of 30, and that gives us a voltage of 6 volts. And what you might notice as a bonus is that the voltages in a series circuit will add up to the supply voltage. Hopefully that one went okay. If you didn't have a clue really, you can just obviously rewind, attempt that again, so get a new sheet of paper. Alright, let's look at another one that's a bit trickier. Let's see how we cope with this one. Alright, so if you want to pause and have a go at this one, it's a little bit tricky, and then I'll take through the answers in a second. Alright, let's have a look. So we've got the circuit, and it says, using the diagram above, calculate. So the first one is the current flowing through each resistor. So I'm going to call this one R1, this one can be R2, and this one R3. So what you need to know is the circuit rules. If you know the circuit rules, this one should be okay. So the total voltage in the circuit is the 5 plus 5. So the total is 10 volts, that's the supply voltage. Now in a parallel circuit, which this one is, in a parallel circuit is simply the current can flow in multiple directions. It splits and joins at junctions, this being the junction, or this being the junction in this case, so you can join back up. So it's a parallel circuit. And what that means is that the voltage on each row is the same. So a row would be, for example, this is a row. So there's 10 volts on that row, 10 volts on this row, 10 volts on this row. Now because we've got the voltage on each row, which is 10, they're all 10 volts, and we've got the resistance, we can quite easily get the current. So the first one, so the current in 1 and 2, which will be the same because they're both in series with each other, will be the total voltage on that row, which is 10, divided by the total resistance on that row, which is 50. So the total current on that first row, current is voltage divided by resistance, 10 volts divided by 50 ohms. So that gives us 0.2 amps. So that's R1 and R2. And then let's do R3. So the current for R3 is the total voltage across that resistor. And there's only one resistor, but it's still 10 volts, divided by the resistance of 60 ohms. And that gives us a current on the bottom row, which is equal to 0.16 recurring amps. So that's the first one done. Next one, the voltage of each resistor. So we've got the voltage V1 on this one, V2, and this bottom one's obviously V3. So to get voltage, you just need to do current multiplied by resistance. And we know the current for each one, so we just need to multiply by resistance. So V1 is the current, which is 0.2 amps, multiplied by 20 ohms. So that gives us a voltage of 4 volts. Now you could do the same for the second resistor. It's just 0.2 times 30, which is 6 volts. Or you could have established that the total voltage on the row is 10. And we know that the resistor 1 is 4 volts, so resistor 2 must be 6 volts, because the 4 and the 6 must equal the 10. And then let's do voltage 3. So I'll just write V2 is 6 volts. Then let's do the bottom one, V3. So the current going through that one is 0.16 recurring, multiplied by the resistance of 60 ohms. So the voltage is, you guessed it, 10 volts. Which I don't know why I've done that, because I told you earlier that it was 10 volts, but it's been a long day and it's extra practice anyway. Right, last one. No more mess ups. Number 3, the total resistance of the circuit. So total resistance of the circuit. Let me make some room. I'm just going to rub that one out. So we're going to use V equals IR. Rearrange for resistance. So that's voltage divided by current. We've done that a few times now. So the total resistance would be the total voltage, which is 10, divided by the total current. So the total current would be the 0.2 add the 0.16, because those two currents would actually add up together back at the batteries to give us the total current in the circuit. So we do 0.2 plus the 0.16 recurring. And that gives us a total resistance of 27.3 ohms. Hopefully that went okay and you found that useful. Thanks for watching, and I'll speak to you soon.